Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, question 6. In the diagram below, the angle CAB, okay, so it's always the letter in the middle, so at A, so up here, is 80 degrees. The angle DCE, so I'm looking for C, okay, is 60 degrees. The angle ABC is x plus y, and the angle BCA is 3x plus y, where x and y are natural numbers, okay? I love when they have a diagram. It's great because it makes sense out of this. Find the value of x and the value of y. Okay, interesting. Okay, so this is geometry, okay? So you're looking out for things. This is all the theorems and the statements that are on your course that you need to be familiar with, okay? An example of one that we will use is angles in a triangle add up to 180 degrees, okay? But the other one that I see before that is in fact here, okay? I see an X, okay? And when I see an X, as such like that, okay, I see vertically opposite angles. Okay, and these are equal. Okay, so straight away I can go 3x plus y equals 60 degrees. Okay, in other words, this angle here equals this angle here. Okay, so this side is equal to this. Okay, now that angle here is also equal to that one. It's just no good to us. Okay, so I hope that one makes sense. 3x plus y equals to 60. Now, the other thing my brain is thinking about here is I have two unknowns here in the one equation, x and y. Now, for as long as there's two unknowns in the one equation, you can't solve it straight away. So two unknowns typically means simultaneous equations. Okay, so that we'll end up solving both letters simultaneously or at the same time. Okay, so I'm going to put the number 1 beside that because to me this is very much looking like simultaneous equations. Okay, and I park that for now. So that's what my 1 means. I can't do any more with that. I have no way of figuring out what is x and y. So for example, I could guess that x was 10 degrees, for example. So this would be 30 degrees. So then y would have to be 30 degrees. Do you see that? So it just becomes a guessing game, okay? X could also be 15 degrees. So 3 15s is 45 degrees. In that case, y would have to be 15 degrees because, of course, they all have to add to give me 60. And I have no way of figuring out if any of them is correct. I have no way once there's two unknowns in the one equation. So I have to park that for now, and I have to set up another simultaneous equation so that I can solve it. So the next theorem or the next property I see is, of course, the angles in a triangle. Okay, so I'm going to do this one in pink. Okay. And for this one, angles, get a bit thicker so you can read it, angles in a triangle add up to 180 degrees. Okay, so therefore 80 degrees plus x plus y plus 3x plus y equals 180. Okay, so I wasn't at all bothered by whatever is the angle. I know that the three angles add up to 180. Okay, they can call them whatever they want. They can put whatever letters they want in them. You try not let it phase you, and you try and use the properties that you know about shapes, because that's what geometry is. It's the properties theorems and axioms and whatever they want to call them, but they're all the statements about shapes. So angles in a triangle add up to 180. So there's my 3 angles. And I then try and tidy it up a bit because I suppose I'm figuring I have to go simultaneous equations. So the easier I have it looking, the easier it's going to be for me to solve. Okay, so let's add the x's together. I have 3x and x is 4x. I have y and y is 2y. Okay, I'm going to bring or subtract 80 from both sides. So I have 4x plus 2y being equal to 100. And that to me now looks like it's in its simplest form. Can't do a whole pile more with that. So there goes my number 2 around it. Okay, and there's my set of simultaneous equations. So let's solve them. So now it no longer is an algebra question really. Now it's your geometry. Oh, sorry, now is your algebra. So from algebra, you can cancel the x's or the y's. The reason you cancel the letters, one of them, is so you can solve the other one. Okay, so for as long as you have one letter, you can solve it. Okay, we can solve that if we could get rid of the x's. And then once we know what the y is, we can sub it back into an equation to find the x that we cancelled. And when I say you cancel one of the letters, what you end up doing in simultaneous equations is adding. So to cancel a letter, you make them add to be 0. Okay, so to do that, you'll need one of them to be a plus, you'll need one to be a minus, and of course you'll need the same number in front of them. So I could cancel the x's. So the numbers these would have in common is 12. Okay, so I'd multiply the top one by 4 and the bottom one by 3 to bring both of these up to 12x. That's the smallest whole number that 3x and 4x will divide into. Or I can cancel the y's. This is 2y, so I just need to multiply the top one by 2 and it'll bring it also up to 2y. So do you know what? I'm going to do that one because I like to do the easy stuff. Okay, so this is how I would naturally do it in a test. Okay, so 4x plus 2y equals 100. Okay, I don't need to do anything to the bottom one because multiplying the top by 2 makes them the same. Okay, now watch what I did. I can't just multiply the y by 2. I have to multiply the whole equation by 2 to preserve the equation or keep the equation balanced. The left has to equal the right. So if I'm going to double the left, I have to double everything. Okay, now they still won't cancel to 0 when I put a line under them. Okay, why? Because I've got a plus and a plus. So when I add them, I actually get 4y. So they're not cancelling. So you must change the signs all the way across of one of your equations. And again, doesn't matter which equation, whichever you prefer. Some people always do the bottom one, but it really doesn't matter. And then you add or take away, as in this case, because it's 6x plus minus 4x, or 6 minus 4 is 2x, plus 2y minus 2y cancels to 0. 120 minus 100 is 20. Divide by the number in front of x, and we're getting x is equal to 10 degrees. Okay, so that's my x value. To find my y then, I sub it into either equation. Simultaneous equations have the same answers for x and y. That's what makes them special, okay? So you sub it into whichever equation you think looks easier, okay? And I think this one does. It's got a single y in it. It's not that much easier, but it's a little bit, okay? So sub in to 3x plus y equals 60, okay? So I found that x is 10. So I'm putting in 10 for x. I now know what x is. So that's 30. Subtract 30 from both sides. So I'm getting y being equal to 30 degrees. So x is 10 degrees, y is 30 degrees. And of course, an easy check is here to see, is this 60 degrees in my vertically opposite angle. So 3/10 are 30 plus the other 30 from y is indeed 60. So I'm quite confident in my answers then. Okay, so that's how you do part A. Part B then, in the diagram below, D is parallel to FH. DH, okay, is 5 centimeters. HE is 12 centimeters. HG is 30 centimeters. And the distance from D to F is X. It says find X. Okay. Okay, and we have parallel lines. Okay, so I'm going to put in my little tick marks on my parallel lines. So DE is parallel to FG. So those little arrows there mean parallel. Okay, so it's kind of always good to mark them in. Okay, so from an angles point of view, it means that angle up there is actually the same size as that one. Okay, it has to be to keep these angles or these lines at the same slopes so that they never meet and therefore remain parallel. Okay, so they must be at the same slant or slope, which means that those angles must be equal. Or if you know your corresponding angles are always seen using the letter F. So I don't know if you saw me doing the F, I'll do it there again. So you always start, the arms of your F are always parallel lines. Okay, and therefore these are what's called corresponding angles and they're equal. Okay, so that's another way to figure out that those angles there were equal. Okay, right. So how do we do this? Well, it's what's called similar triangles. Okay, and the key to it is you have a triangle here. The key to it is not to see this shape as such, okay, because that's not a shape on your course. You know, it's not parallelogram, it's not a rectangle, it's not a triangle. So the two shapes you need to see are the small triangle and then the big triangle. Okay, so I'm going to draw out those two triangles. Just delete off the corresponding angles. Okay, so there's one triangle. H, D, and E. Okay, and then the other triangle is a bit bigger. Okay, and that's H, F, and G. Okay, so the big triangle is this one. The small triangle is this one. Okay, now when you see a little triangle in a big one, chances are they're what's called similar triangles. Okay. I can't just write that down. I have to show that the angles are equal to say that they're similar triangles, because that's what makes triangles similar. Their angles are equal, but one triangle is like a blown up version of the other. Okay, so the first thing I'm going to write down is that the angle, so that one at F and this one at D. So let's describe the small triangle first. So it's the angle HDE. Okay. I could have also called it EDH, okay? As long as D is the letter in the middle, I'm describing that angle up there at D, okay? And that's equal to the angle HFG, okay? And of course, again, I could call it GFH, okay? Y, corresponding angles. So you have to write down the Y. Okay, right. The second one I'm going to say then is that this angle is equal to this one. Okay, why is that the case? So let me write it down first. So DHE, I just need the H to be in the middle. The angle FHG. Okay, why? Well, it's actually the same angle, isn't it? Okay, it's just part of the two triangles. It's the letter H. So it's the same angle, part of the two. And I would say then the other angle, and I'll color this one in red. So G must be equal to the angle at E. Okay, that's the one I'm describing now. So in the small triangle, that's DEH is equal to the angle FGH. Why? Because it's the third angle in a triangle. Okay, so because they all add up to 180, a fixed amount, if these angles are the same value, then isn't there the same amount left over for the remaining angles in each triangle? So they must also be equal. Okay, so I have now shown that the angles in the triangles are equal. Okay, so therefore angles are equal. Therefore triangles are similar. Okay, and again, there's a theorem on your course for similar triangles, and it tells you that the sides are in proportion. Okay, so in other words, when you have your two triangles lined up so that the matching angles are in the same position. So do you see the way D is equal to F? So we're lucky enough, these are rotated the right way. The D angle is at the top and the F angle is at the top. The H angle is on the left here and it's on the left here, okay? And the E angle is here and the G angle is here. So the two triangles are lined up to match each other with their matching angles. And when that's the case, I can say that the length of this side is proportional to the length of this side. The length of this side is actually proportional to the length of this side. And the length of this side is proportional to the length of this side. So what does that mean? Well, it means that essentially this triangle is a blown up version of this one. It's an enlarged one. So it could be that FH is twice the size of DH. It could be HG, then it'd be twice the size of this one, and this one will be twice the size of this. So the ratio will be the same. So let me write that down so you can see what I'm writing. Okay, so what I'm saying is DH is proportional to HF or FH. And these two lines down here means the length of. And that would be the same value as if I took DE and divided it by FG, which would be the same value as if I took the bottoms, HE over HG. Okay, and that's the theorem that's on your course. If the angles are similar, if the triangles are similar, then their sides are in proportion. Okay, so I'm going to get the same value when I take the ratios of the sides. Okay, so that's all fine and well. One final thing I'm going to say about setting up this ratio is that you have to be careful. Because I started with the small triangle on the top here, I had to make sure that it was the sides of the small triangle that was on the top all the way across, okay? I could have easily started with the big triangle on the top. That would have been fine too, but I'd have to make sure that the big was all the way across. Okay, and then you fill in the information that they give you. Okay, so DH is 5, HE is 12, HG is 30. Okay, and that's all the information they've given me. And then they've asked me to find X, okay? So this DF, I don't have a DF anywhere on my diagram, okay? So the only way I can get at this side, this measurement X, is to actually find the length of this entire side. And then if I subtract the 5 off it, I'll be left with what's left at X. So in fact, I need to find that side FH, which is on the bottom here. And you won't be too surprised that I'm sticking a letter X in on top of it. And what you'll see is you'll only end up using two pieces of the theorem at a time. We don't have any information about that side, nor do we need to take any measurements off it. Okay, so I'm basically left then with 5 over X being equal to 12 over 30. And we cross multiply to get rid of the fractions. So that means that it'll be 5, follow the cross. So 5 multiplied by 30 is equal to, and follow the cross the other way, X by 12 or 12X. Okay, and I want to solve that one for, maybe X wasn't the best letter to call it, because you might get confused between X in the question and my X, okay? So how about I call that Y instead? Okay, I hope that makes sense to you as to why I'm not calling it X. Okay, so 5 by 30, because you can see it doesn't matter what letter I call it. I'm only using it for a placeholder until I solve it. So I've got 150 is equal to 12y, divide by the number in front of our letter. So 150 divided by 12 is 12.5. Okay, so I've got that full side here is 12.5. Okay, so therefore, and this is why I changed the letter, x is equal to 12.5 minus the 5 centimeters that's already there, because I just want this part of it. And I get 7.5 centimeters for x. Okay, so that is how you use similar triangles.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in Electronics and Self-Driving Technologies, and from there to the Masters.
Check out the link below for more information.